The third part I will introduce is the characteristics and organizations of frontal score lines, and a special case in 2014 is taken for example. A linear convection with a ratio of 5:1 and a length over 500 kilometers is defined as a score line process. Score line occurs and develops in the surface low pressure or in an area over 100 meters in front of the cold front, which is defined as a warm sector score line. Score line accompanied by surface front is defined as a frontal score line. From 211 to 216, from March to June, a total of 29 score line processes affected Guangxi, with 16 warm sector score line and 13 frontal score line. From the above two figures, we can see that warm sector score line mainly occur between April to June, with an average of 6 score line every month in the 6-year period, while the score line process related to cold air mostly occurred in April, with a total of 5 processes and 4 processes in May. Compare the disastrous weather caused by the two kinds of score line. Warm sector score line cause more thunderstorm gales, and frontal score line bring about more hail. From the gale distribution by score line, gale by warm sector score line occurred all over Guangxi, mainly concentrated in central part of Guangxi, showing a north-south zonal distribution. Gale by frontal score line are mainly concentrated in eastern part of Guangxi, especially in northeast Guangxi, where cold air is active. This is the frontal score line that happened on March 30, 214. It can be seen from radar echo evolution that the initial convective cell first moved from southwest Guizhou to northwest Guangxi at midnight on March 30th. The convective cell first moved southeastward and gradually merged into the east to west and then moved southeastward. And the short linear convection first developed into the bow echo and last into the long score line. The score line moved out of Guangxi at around 8 p.m. the next day, lasting for about 12 hours, with the moving speed of 70 kilometers per hour, which is a fast-moving frontal score line. And convection was triggered by the west of the front, where the front convergence line and dew point front. When high trough was closed, the convection is induced. Above is a common form of the frontal score line in spring in sea. From the path of the convection, we can see that the convective cell was generated in southwest of Guizhou and then moving from northwest to southwest. From the distribution of gale and thunderstorm, from this score line process, it caused 24 station gale and only 15 station thunderstorms in Guangxi. It affected northwest Guangxi first, and then southeast Guangxi, and northeast Guangxi was its main falling area. A part of the station has strong wind without thunderstorm, which is because of the large pressure gradient. In terms of the 24 hours accumulated rainfall distribution, heavy rainfall was mainly concentrated in the northern region of Guangxi. From the hourly rainfall distribution, it can be seen that there was only 1 or 2 hours with hourly rainfall more than 30 millimeters, indicating that there was only 1 or 2 mesoscale system was short transit time during the inference period of the score line. And this is the path diagram of the frontal score line. More than 80% of the score line move in accordance with such a path. Different cases of score line have different length, but they all involve from line convection to bow echo score line. This kind of score line can be forecasted 24 hours or more in advance because numerical prediction model is quite accurate in predicting the cold air, but there was some error in the time, speed, and intensity. According to the arrival time of cold air, we can imagine or forecast the arrival time of the score line and then forecast the severe weather such as strong wind, thunderstorm, and heavy precipitation. Frontal score line weather system configuration. This is the weather system configuration before the frontal score line was triggered. At 500 million bar, there is a upper trough approaching west of Guangxi with an obvious cold trough behind. There were a wind range of cooling area before the upper trough, the cooling reaching 2 to 4 degrees in 24 hours. And second is the subtropical jet passed over the northern part of Guangxi, and it provides very good vertical wind shear condition for severe convection weather. The positive vorticity advection in front of the upper trough also provide dynamics conditions for the development of the lower layer system. At 850 million bar, the shear line was in the north of Guangxi, and the northeast to southwest lower level jet was in the southeast of Guangxi. The eastern part of Guangxi was in the convergence ascending area between the exit area of the jet stream and the axis of the jet stream. Meanwhile, the low-level jet is conductive to water vapor transport. The warm ridge extended from the north of Indochina Peninsula to Guangxi. The shear line by south wind and southeast wind in central Guangxi at 925 million bar boundary layer is conducive to upward movement. On the ground, there is a cold front from Guizhou to North Guangxi and a surface convergence line at the junction of Guangxi and Yunnan. This is the sounding of north of Guangxi before the convection weather is triggered. The temperature profile and dew point profile shows the structure of upper dry and lower wet. The layer under 800 million bar is saturated. 6 km vertical wind shear reaches 22 meters per second and 3 km vertical wind shear is 8 meters per second. Strong vertical wind shear of the middle layer is conducive to the development of deep convection, and Cape reaches about 800 joules per kilogram, and level of free convection is about 30,000 meters high. The temperature difference between 815 million bar and 500 million bar reaches 28 degrees, which provide good thermal instability condition for the occurrence of convection. And before the check of the convection weather, there was a stationary front in the northeast of Guangxi. In the late afternoon in southwest Guizhou, the convection developed and moved along the stationary front. This is the summary of the frontal score line. First, the score line was triggered by the front, and with the cold air advancing towards the southeast direction, the multi-shear storm evolved into a long score line and moved southward. Second, before the occurrence of convection, Guangxi was located in front of the upper trough with upper dry and lower wet stratification, which was favorable for convection development. Now let's begin part 4. In this part, I will introduce 4 warm sector score lines, including impacts on weather systems and environmental conditions, radar echo features and mesoscale systems, and some statistical features of warm sector score lines, as well as difficulties in forecasting. Warm sector score line. In these 6 individual cases from 2013 to 2016, the warm sector score lines were distributed in the northeast to southwest or north to south direction. Different from the frontal score lines, warm sector score line mostly moved from west to east and partly from southwest to northeast. The movement of score line was closely related to ground outflow and middle level guiding airflow. The above warm sector score line adhere to the conceptual model of a score line with a leading convective line and a trailing stratiform region. This picture shows the moving path of larger than 35 dBz radar echo profiles of the 6 warm sector score lines. Score lines were initially generated in south of Guangxi or outside of Guangxi and then into Guangxi. And in the development process of score line, they mainly moved towards the east direction. During this all 6 process, there were bow echo forming, which result in thunderstorm gale in Guangxi. The minimal maintenance time is just 5 hours, and the maximal is 10 hours. The moving speed is 50 to 80 kilometers per hour.